Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shahroz Abdullah and today we are going to discuss what is motion of freely falling bodies and also we are going to discuss the numerical problems of chapter number 2 class 9 physics lecture number 5 kinematics. Okay. Let me recall the previous work what we have done yesterday. If you remember in the previous lecture we have done with all the three equations of motion, their graphs, their derivations and their proofs, their values, all the things we have done in the previous lecture, right? Now in today's lecture we will discuss how the motion of freely falling is observed. Free falling bodies is observed. Let's discuss historical background of it. Leaning Tower of Pisa, the first attempt was done by Galileo. He just threw some of the objects over there and observed that if air resistance is neglected, all the bodies irrespective of their masses reaches to the ground in the same time, means all the bodies heavy or light fall with the same acceleration towards the ground if the acceleration if the air resistance is neglected over there. Okay, so this was background of it. Okay, how we define it: the motion in which air resistance is neglected and the acceleration is nearly constant is known as motion of free falling bodies. Okay, acceleration due to gravity value is 9.8 meters per second square or 10 meters per second square. Okay, and now how we can define it: gravitational acceleration or acceleration due to gravity, both are same thing. The acceleration of the freely falling bodies is known as acceleration due to gravity. It is shown by small g. The value is 9.8 meters per second square or 10 meters per second square, but this is for surface of earth value. Okay, now these values may be positive as well, these values may be negative as well. Do remember one thing: if a body is falling towards the earth, g value will be positive, 9.8 meters per second square, while if a body is thrown vertically upward away from the ground surface, the value of g will be minus 9.8 meters per second square. Okay, equations of motion for bodies having under gravity, s is replaced by h while a is replaced by g. Okay, so Vf is equal to Vi plus At will turn to Vf is equal to Vi plus Gt. S is equal to Vit plus half At square will turn to H is equal to Vit plus half Gt square. Okay, and third will turn to 2As is equal to Vf square minus Vi square. So this will turn to 2Gh is equal to Vf square minus Vi square, right? So this was all about motion of freely falling bodies. Now let's come towards numerical problems of chapter number 2. Let me discuss the statement first. Okay, what does it says in the statement? Let me read the statement. A squash ball makes contact with the squash racket and changes velocity from 15 meters per second west to 25 meters per second east in time 0.10 seconds. Okay, initial velocity is 15 meters per second, that is west. Final velocity 25 meters per second, that is east, and time is given to you 0.010 seconds. Okay, what does it say? Determine the vector acceleration of the squash ball, or you can say just acceleration. Okay, we know that Vf is equal to Vi plus At. Okay, since the directions are opposite, so we will put minus over here with the Vi value. So we convert this, like shift it to the from right to left side. So this will give you Vf plus Vi is equal to At. Or for finding acceleration, divide time or on both hand sides. So we get the equation A is equal to Vf plus Vi divided by T. Okay, Vf value is 20. Just by putting the values we can have the answer. Look, Vf value is 25, Vi value is 15, time is 0.010. Just put over there and reach to a result of 400 meters per second square, which is the acceleration value, right? Now you can write the result as well. Okay, now let's discuss numerical number 2. A golf ball is that is initially traveling with 25 meters per second. Okay, hits a sand trap and slows down with an acceleration of minus 20 meters per second square in time 2 seconds. Okay, Vi is 25 meters per second, acceleration is minus 20 meters per second square, time value is 2 seconds. Okay, what is required? Distance is required just by using displacement is required. Just by using second equation of motion we can have the result. Look, S is equal to Vit plus half At square. Just by putting the values, Vi value 25, t value is 2 plus 1 by 2, a value is 20, t value is 2 square, and you will get to a result of 10 meters, right? So which is the required displacement covered by the golf ball, right? Okay, we are going to discuss the third numerical. Let me read the statement. A bullet accelerates the length of a barrel of a gun 0.750 meters. Okay, distance is given to you 0.750 meters. Okay, with a magnitude of acceleration is how much? 5.35 into 10 to the power 5 meters per second square. Acceleration is given to you. Okay, with what speed does the bullet exit the barrel? Like with what speed the bullet will exit from the barrel? Okay, do remember initially the bullet was at rest, so Vi will be 0 over here. Just by we are supposed to find Vf value, so using third equation of motion, that is 2as is equal to Vf square minus Vi square. Okay, so we get to as is equal to V2as is plus Vi square is equal to Vf square, or we can write that Vf square is equal to 2as plus Vi square. Just by putting the values we can have the answer. Look, Vf square is equal to 2 multiplied by 5.35 into 10 to the power 5 multiplied by 0.750 plus 0 square. Just by putting the values we can have the result. Vf square is equal to 80.25 into 10 to the power 4. We want the value of Vf. What to do? We are supposed to take and square root both hand side, and we are going to reach to a result of 8.96 into 10 to the power 2 meters per second, right? So which is the required final velocity value. Okay, now coming towards statement number 4, like numerical question number 4. It says driver is traveling at 18 meters per second. Okay, initial velocity is 18 meter per second. Okay, when she sees a red light ahead, her car is capable of deaccelerating. Deaccelerating means negative acceleration. We have to put negative sign with the given value at a rate of 3.65 meters per second square. A value is minus 3.65 meters per second square. If she applies brake when she is only at a distance of 20 meters from the intersection. Okay, distance is how much given? S1 value is 20 meters. Okay, do remember when the car will stop, the final velocity will become 0. Okay, will she be able to stop the car in time? Okay, before the question is, will she able to stop the car in given time? Okay, do remember one thing. Let me find S2 distance. Okay, on behalf of S2 distance we will decide that will she be able or not. Okay, using third equation of motion, that is 2as2 is equal to Vf square minus Vi square. The equation is same, just I am writing 2 over here. Okay, this will give you S2 is equal to Vf square minus Vi square divided by 2a. Just by putting the values in the given equation you can reach to a result of 44.4 meter, means which is very greater from 20 meters, which is clearly understood that she will be unable to stop the car in the given within the given range. Okay, coming towards question number 5. It says an antelope moving with a constant acceleration of 2 meters per second square, acceleration value is 2 meters per second square, crosses point where its velocity is 5 meters per second, acceleration value is 2 meter per second square, initial velocity is 5 meter per second square, given time is t is equal to 6 seconds. Okay, how much distance it has covered and what is its velocity? Okay, distance covered is supposed to find, and final velocity. For finding distance covered using second equation of motion, s is equal to Vit plus half at square. Okay, just by putting the values in the given equation we can reach to a result of s is equal to 66 meters. Okay, coming back to part number B. For finding final velocity using first equation of motion, Vf is equal to Vi plus At. Just put the value in the given equation, 5 plus 2 multiplied by 6, and reach to a result of 17 meters per second, which is the value of final velocity. Coming to the last numerical of this chapter number 2. What is it? With what speed must a ball be thrown vertically upward from ground level to rise to a maximum height of 50 meters? Okay, final you are throwing a ball. Okay, you are supposed to find the initial velocity, and do remember the ball will move upward, and after reaching a certain point definitely the final velocity is going to become 0. Okay, h value is 50 meters, and we know that this was given. And okay, using third equation of motion, 2as is equal to Vf square minus Vi square. But since this is gravity case, so the equation will turn to 2gh is equal to Vf square minus Vi square. Okay, just by putting the values we can reach to a result 2 multiplied by minus 9.8 multiplied by 50 minus 0 square is equal to minus vi square, and we will reach to a result minus 980 is equal to minus vi square. Minus will be finished from both hand sides. Vi square will be equal to 980 meters per second square. Just taking square root on both hand sides, you can reach to a result of vi is equal to 31.3 meters per second square. So this was all about numerical problems, right? Let me summarize today's work, what we have done. In today's lecture, we have discussed the motion of freely falling bodies, and we have discussed the historical background, definition, gravitational acceleration, their value, positive, negative, and the equations of motion in terms of gravity. Also, we have discussed all of the numericals of chapter number 2, kinematics. All the numericals are discussed. Hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz. Fi Aman Allah.